Hello everybody, welcome back, and this is session 2 of 10 session in my training classes. This is afternoon session of day 1, but it's often extended to next day because the chapter is huge chapter. We're going to cover the set function. This is one of the most crucial chapter in the course as well as the MDX. You need to know very well this chapter. Okay, so I even go second day after lunch till after lunch. The same, basically 2 session cover the same one session. The reason I didn't separate out because these are all functions together. We have some sessions are very small. I mean, one session I know it's very small. It doesn't need even an hour. So in total it'll be fine. So okay, so the agenda for so the agenda for this session actually divided into 3 different parts. First part is very simple functions like head, subset, top count, top percent, etc. And it have a similar functions we have here, and it's very similar. So I just want you to do exercise 4 exercise or something like that. So that should be covered. So head, I don't want to do another tail, so you guys do that. And then my second part of the functions are, these are the functions. We have descendants, which pretty detailed. I go through. I have 4 different cases for descendants. Add, calculate members, filter you already used, and set functions. You all know union, intersect, and accept. We're going to go through this. My third part is very important. Okay, my third part is very important. Okay, the cross join. Unlike SQL Server, we do a lot of join in MDX. The extract, the non-empty cross join. Range is okay. Range is very simple. Exist also important. Most important is our generate function. Very important here. So this part is, I will say, very hot topics. Okay, these are okay topic. Sorry. These are okay topic. These are I mean, one of the function, descendant function, is very important, and it's so okay, but this function is very important and you need to concentrate very well. Okay, so it's this session have a mix of things. Okay, so let's start. So let's start with our first query. List first 5 product from the list of all products. Okay, so that's my start. Okay, this is my first query, and I should open my SQL Server Management Studio. connect to analysis services, my server, and connect to the database, the Conteso DW, and we should connect to the our operation cube. So query is find first products from the list of all products. Okay, so first five products means in the list find the first product. It is not sorted by any number, anything, whatever the list it is, just select first five. Okay, so we are not sorting by anything, there is no particular order, whatever the existing condition is. Okay, so in that case we know select empty in columns because we want have only one list. So on columns empty, and here in the rows we are going to select, on rows we are going to select all products, say for example. Okay, and from cube operation, okay, and we're going to select all products. So product, we have a hierarchy product and the product name. Okay, so that's the all product. And if you want to select the first five, there's a function called head, that is my first function, head, and head takes two parameters. First parameter is a set, and second parameter is how many items you want. So yeah, head of this set, and you want 5, right? So first five product, that's your first five product, correct? Say you want to display some measure for this 5 product, and say we want to display the sales quantity. Okay, F5, that's give you this value. So we have first 5 products and sales quantity. Okay, good. Normally I ask a lot of do you have any question, but unfortunately this is a video, so I believe I answer all the questions, and there is no everything is very clear. And again, if I miss something and you really want to know, you do the reference, you have a password for your video and refer to that password, explain which chapter you are talking about, which page you are talking about, and what query you are talking about, and you can send email to me, and it is training@egurus.com. Normally you send an email to this, then I'm going to give you some other information, some other emails where you're going to send the email. Okay, so that's the okay. So my next query is the same query, list first 5 products from the list of all products, but use the function subset. Okay, now what is subset? We're using the instead of head we have a subset, but subset have 3 parameters. This is the same set, and first parameter is the start location and second parameter is a item count. So in this case, subset function returns items from any part of the list. Head function returns only from the head, whereas subset function returns from any part of the list, right? And starting location, second parameter of the subset is a starting location with 0 based index. Okay. Third parameter of the subset is the number of items you want to return. Okay. So you have you can have a subset function, subset, and you say my starting location is 0, my item count is 5. So that's the starting location and item count. Okay. Now you can do like, okay, if I can be like 10th position. Okay. So it's good. How many? If we have like 1,000 or 2,000 products, and we were going beyond that, definitely not going to return anything. In fact, I know the number count is like 2,500 something. Okay, so if I give around 2,000, it should still give me 5 product. Let's see. Yes, I believe it is around 2518 or something like that. So let's do 3,000. Okay, so it's giving nothing. So 25. Let's see, 18, if I remember correctly. Okay, 7. Okay, so that's this last member. So 6 is this. Now my question is how you find how many products you have. Just now we are looking, okay, how many products we have. Okay, so how you are going to find it out? Should be very simple. So we're just going to go as a dot, so dimension hierarchy level, and dot count should give us a count, right? How many, but how you are going to display? So let's create a member, calculated member with member, and then measures. Careful, it's not measure, it's a measures. Okay, dot, say product count as, that should be give us a value, right? And how we're going to display is select on columns from, we don't need rows because we have only one value to display, operation. Okay, I have a misspell, operation, and that's your product count. Okay, so that should give us a product count 2518. Okay, good. Next query. Next function is top count, right? And we have a query, so let's find out the query. Okay, This is a different function in the subset. There's a definitely head and subset have a difference, because head you can see only the, you can get only the beginning of the set. Subset you can have any part of the set. Top count is different. So let's open another query. So that's our query. List top 5 products from the list of all products. Okay, that's good. Based on sales quantity. So it says that select, first you sort the set by sales quantity, descending order, and then select the first 5. So let's copy the old query. I'll just, because it's very similar, I don't do. Okay, so this is good. We're going to do top count. Okay, and how many products we want? 5 products, and based on it also have a 3 parameters. So first is set, second is how many product, and third is what you are sorting by, sales quantity, or sorting by sales quantity, right? So that's our top 5 products based on sales quantity. Okay, maybe sales amount, it may be different because not all product have similar cost. So so it depends what you want. So sales quantity, this is 415,880 and then 415,700. So that's your top count. Top count first sort by sales quantity, right, and then select top 5 product by descending order. Second parameter top count is the number of items you want to return, and third parameter's top count is the name of the attribute for sorting of top count. Okay, good. So here another most important thing is you need to very sure that where is your brackets and set finishes. That's the reason I put an arrow and make sure this is the set. Sorry. Okay, sorry. So this is the set, then this is top count, top counts parenthesis, beginning parenthesis, this is end parenthesis. These are first set, this is a set, this is the item count, and this is the measure we sorted by. Okay, good. Okay, our next function is top percent. Okay, so top percent, I'm just trying to use the same so that we don't have to retype everything, because these are very similar functions. Now this is exactly same query, only says that instead of top count it's a top 5%. Instead of top 5 products, it's a top 5% of a product. What do you mean by percent? What does this percent means? Percent means percent is based on sales quantity. It have exactly same. Say we have a okay, it's exactly same, and percents means the cumulative value should be more than 5%. Okay, now what is 5%? What is 1%? So let's find how many total sales quantity we have. Okay, so I'm just copying this part and I make new query and operation, paste, and I just want to find out what is the total sales quantity first. Okay, so this is my total sales quantity. So if this is my, I'm copying and pasting here. If this is my okay, I'll do here, but okay, let me go back here. Okay, so this is my total sales quantity. Now if it's a 1%, just in very approximately, you can remove this last two digits, right? So this will become 1%, right? I'm giving a approximate. Basically is 1% is this much. Okay, let's do calculation. Okay, let's do that, no problem. If this is your 1%, my calculator, okay, can I do that here? Okay, good. So 533204, this is 1% into 5 should give me 5%, right? So it is, how much is that? $2.6 million around. If it is, if this is the amount, so to make it 4, so it's around 2 million. So let's display this. We are still have a top count, right? So let's do 10 count. Okay, top 10. So I'm just trying to get 1 2 3 4 5. 5 is around 2 million. 6 7. This will touch the 2.6 million. So around, this is around 2.8 million. So 1 2 3 4 5 6 7. 7 will show up, right? So you got it right. So 1, if we do top percent, and if we do 5, then 7 will show up. First top 5 products, sorted by sales quantity in descending order, select first number of products to make 2.6 million, right? So F5 should give me 7. 1 2 3 4 5 6 7, and that is 2.8 million. So if we say 1%, this is our 1%, how many product will show up? First doesn't touch for around 500,000. You need 2 to touch around 500,000. So if 1, it should show me 2 values. Good. So you're very clear on that, right? Top percent is cumulative total of the total should be more than the percentage defined. 1% is 533,204.54, that many. Now we say 1%, it says first 2 product, so that it touches 800,000, which crosses the 533,000. It should be crossing. Okay, So that is our top percent. Okay, I hope it's very clear. People got confused a lot on this this top percent actually. So another thing is, this is top 2p, top percent. Do not confuse with the 1p. 2%, I mean 2p. Okay. So it's a cumulative total. Okay. Next, order. So you already know what is the order. We did some sorting. So let's go for our order. New query. And cut and paste. So it says display sales quantity for the product categories. Okay, and sort by sales quantity. Okay, okay, that's good. So what you can do, we're going to display columns. We're going to display the sales quantity. It doesn't say you need to display, but no, it says display sales quantity for product categories. That's good. So it is telling, so sales quantity for product categories. So this is our sales quantity. Okay, so this is our sales quantity here on columns, and then on rows we want to show the product categories, right? Product categories, and product categories is here. Okay, product categories on rows from operation. Okay, so this should show us the product. Okay, product category and sales quantity. Now if we do order, okay, and you can order by the measure code sales quantity. Okay, so now it should be sorted by. Okay, sorted by, we want to know how you want to sort by, ascending or descending. So ascending will be null first and then all value. Okay, F5, null first, then increasing values, right? It should be good because all are in the same level. We don't have to use break, or you can use break and non-break will same result because all are in the same level. Okay, so I'm going to add one more query here. No, it's not in your training booklet. So as I said earlier, normally I not skip anything from the training booklet, but as the time goes I may add new things in the video, because just now I feel that you should have one more ordering. I should give you one more example. I know you guys are very smart, but I believe if I explain a little bit more, it will be more clear to you. Okay, and it's very simple, very simple. So we have sales quantity. Earlier also we did by sales quantity. Question is, if I don't want to sort by sales quantity now. I want to order by name. This name. Okay. A lot of time, in the MDX, when I was learning, I could not find anywhere people give only one example, and that is online books, and everywhere you go, same example. So people don't, So I was trying to understand, and that's the reason I'm creating this video, and trying to explain more detail, more example, and I believe you guys love it. And definitely send me email if you got a feedback and everything, whatever, or your feedback, anyway. So I want to say here, we want to display by the product name. So how are you going to do that? So sort by, instead of this is a descending order, you can do also descending order. I'm sorry, I don't want to jump here there. This query says descending order, so you can do by descending order also. Okay, just want to make sure that what query says, and then I cover. Okay, now it's a new query. Okay, new query is display same thing, but sort by product category name. Product category name. Okay, so in that case we cannot. So this is the set, and order, you will say, okay, let's do this product category name, and that should sort by, right, or ascending order, say. Okay, but it will give an error. Okay, why? Because this is a level. Okay, so we're going to add here product category name, but with expression. How are we going to do that? So with member, say measures dot product category, product category name is, so this is our hierarchy. You can do what is your current member of the hierarchy, which is whatever the product category is, dot name. Okay, that's your product category name. Now you can use this one as a sorting parameter. Okay, so now you should be able to see the sorting parameter F5. Okay, so now it is sort by the name. Okay, next, on order. This is also very interesting function. When I was learning, I had a lot of tough time to understand what is this unorder does and why it is, why it is. So this I just give it inspect the query. I didn't give you a particular query and everything. And let me explain what it is. So let me run a query. So let's say we want to find, our query is find sales quantity for product category, and do not show empty values. Okay, so that's our query, and we wrote so many times, so we know very well. On columns, on rows, from cube operation. Okay, and select the right cube, measure, and you select the sales quantity. Okay, and then you select the product category. Should be product category. Okay, so that's our first. Sorry. Which one? I mean to select the from the. Okay. So if we try to find out non-empty, we have to use the non-empty. Okay. And non-empty for sales quantity, for example. So okay, so it is not showing any more null. Now we can use, now we can use a unorder function. Let's see now the definition is, I said definition removes any enforced ordering from a specified set. The unorder function is used to hint there is no physical result from the unorder function. Very important. There is no physical result from the unorder function. It's just a hint. It's just a hint, you know, to Microsoft Analysis Service, Microsoft SQL Server Analysis Service, for query optimization for set processing. Okay, so if we, so this is our non-empty, and we are using a unorder function. So this makes this function to run fast, query optimization. Okay, so that it performance is better. Okay, so unorder function doesn't have any result or any change of the result or something. It will be faster, but how much faster? Very little. If it is a huge for this case, there is no difference. But if it is a huge result or cell set, then there will be a performance change. So in our case here we have this F5. Okay, we didn't put it. So here this set, we'll say unorder. You don't have to order anything, just a non-empty F5. Give the same result, only it increase the performance. Okay. Okay. Next query is a distinct. Again, you guys all know what is distinct means, and I'm going to give example. So just again, this also inspect query. Okay. Okay. So one thing, we did lot of named set. I believe I did. This is the names. Sorry, we did a calculated member. So we create a member. Similarly, we can create a set or name set. Okay. So let's create a set, and I'll say it with set. I'll just say my product categories. My product categories is okay. I will select from okay, I need to select the cube and then find the product category. Let's do a product category and audio. Okay, I was expecting, okay, let's type it audio. So that's our audio, and then say we copy paste, okay, and we're going to type it, no problem. Computers, cell phones, okay, and say we're going to copy computers and paste it here. Okay, so it have a duplicate, so 2 audio, 2 computers, and say we want to display this set. So what do you do? Select on columns, okay, okay, because it's a single set, normally we do in rows, so on rows, okay, from cube population, okay, and we can display this set on rows. F5, this will give you all duplicates values too, all set, because we didn't use anything. So we can do to remove the duplicate, we can use the distinct, okay, function and parenthesis complete F5. So that's give you remove the duplicate values. Okay, so now we are going to do next function is a top sum. Okay, so like top percent, top count, and top sum. Okay, okay, top sum, and then let's see what we have. Distinct, top sum, okay, open a new query, we always do, and select our right cube, cut and paste our query. Show only those product categories which have at least sales quantity 30 million cumulatively. Okay, cumulatively. So we want to product categories, right? Product categories. So same thing, let's do copy paste our, not this one, I'll just close this one. Okay, we have just now we did, right? Okay, this is good, right? We'll just copy this query and here, and we'll change it. We don't want to see the on order, and we want to show simple. Empty is okay. Okay. Only we want to do order instead of empty, so we'll be ordering by sales quantity. So let's see what is the sales quantity. F5. So that, okay, we did ascending order, we want to do by descending order. Okay, so that's the product categories, sales quantity for product categories. Okay, right. So top sum is 30 million. What is this? This is 13 million, 10 million, that is 20 million, 23 million, this is 33 million. So it should show the first three, right? So if we do, okay, let's keep this query so that we can refer later on after comparing. So new query, I just copy everything, new query. Okay, and let's say paste, same thing, F5. So you got this, right? So if we have like top sum, we do top sum, we said what is top sum means. So top sum for this category, and the value we're dealing with this quantity, and we have a 30 million 7 zeros, right? So 30 million. So that should result as first three products, which is cumulatively the value is more than 30 million. So I give here the explanation. It is not individual value. Okay, I just want to explain. That's what my initial one. Okay, okay, this pen is okay. I'm extremely sorry. Okay, order. Sorry. Okay, we are here. So what I was telling, it is not an individual value, it's a cumulative value. As the value increases, it adds the items from the sorted order in descending order. Top sum and bottom sum breaks the hierarchy. Okay, so these are the two things. Okay, so top sum is a cumulative value, so it should display first three, F5, so display the first three. Okay, now if you look at what is this value, it's around how many percent? Top sum and top percent is very similar. So this is, we know around 500,000 is 1%, right? So 30 million is 60%. Okay, so if we do if we replace top by top percent and 60%, it will give the same value. Okay, F5, so give the same value because 30 million is 60% is a little bit higher than 30 million. So you got like top sum and top percent is very close. Okay. So what is our next descendants. This is also very important function. I believe we covered the first part. I believe we covered we are the 11th slides. So this part is covered, right? Okay. So this part is covered. We're going to second part, descendant. So descendants gives the descendant of a member or set. So there's a 4 forms of descendant function. Let me explain one and then we'll compare with the other. So descendant function, first parameter is a member. So for example, it is a country, like we have a country, state, city, right? So that's the example I was using. So if this is the member, say country is a level, United States is a member, okay? So country is a level, United States is a member, so we need a member. United States, Canada, United Kingdom, any country name, okay? Then the distance, if it is 0, this is a country itself. If the distance is 0, there's a country itself, right? So if it is 0, it is country. Sorry, 0 is country if this is country, right? And 1 is states, 2 is cities, right? Cities. So okay, and we're going to talk about this flag pretty detail. So this is the first form. Member is a member in a hierarchy. Because it's a descendant function, normally, I mean, you can have a attribute hierarchy also, but most of the time it is user defined hierarchy. Distance of level, as I said earlier, distance is a distance of level. So if it is you are in a country, 0 is country and 1 is state, 2 is cities. So that is distance of level, okay, from the first parameter. Good. So that's a one form. Okay. Second form, member is member. This is level instead of distance. So here level means you are defining explicitly, say state level or city level, all the levels. Okay. So this is same. These two forms are same, only it have differences here. Level. Okay. We'll talk about this again. Member in hierarchy, level in hierarchy, lower level than first parameters. Normally that's the case. So you guys got it? Form 1 and form 2. Now form 3. These also very corresponding. I mean, I just make a different form. So this is same as this. Only thing is that set. Everything else is same. This form 1 and form 3 is same. This is very similar. Only thing is difference is set. Distance is distance. Set of members in a hierarchy. So instead of United States, we say United States and Canada, United States, Canada and United Kingdom, Germany, France. So that's all set. Instead of one country, it's a countries. Okay. Distance exactly same. Distance of level from the first parameter. Fourth is exactly same as 2. Only difference is set. So set of members hierarchy is a level. This and this difference is this level, and level in hierarchy, lower level than the first parameters. Okay, good. So that's our 4 levels, and we're going to give all the 4 examples. I have 4 examples to do these things. Now, descendant flag. Descendant flag is self. So self is a destination. So if you are dealing with the country, say your first parameter, this one, okay, this is this one is label is country. Okay, this is country, distance is 1, then self, 1 means distance, 1 means state or states, right? States. So self means, in that case, self means state level, right? After means anything after state, which is cities, right? Before, anything before state, before states, which is countries, continents, etc. Self and after, so self and after state and cities. Self, which is state, and before countries, continents. Self before after. Self is state, before is countries, continents, after. And leaves. Leaves is very, very important. So leaves are, like for this example, we have the leaves is state. If we have our destination state, sorry, I believe I confused one part. And so this case we have self is state, right? The first pair is country. So if there is multiple labels and everything, after means anything after states, which is cities. Before means anything before states, including the country. So if there is a multiple steps between state and country, it will include that, but before will not include the continent. Okay, I just want to make sure continent will not be included here. I believe I misspoke. So before means anything before state, which is country. Okay, self and after, self is state and states, and after is cities. Okay, self and before, self is state and before is country, because that is our first parameters. If our first parameter is continent, then that will include the state, sorry, self is state and before be country and continent. If our first parameter, this parameter is a continent. Okay, and self and before and after, in this case it is going to do self, state, country and cities. If it is a multiple levels, that it will not include the continent. That's what I want to make sure. Okay, leaves, in this case leave is our destination is state, so this is different. No, this is a these cities are not leaves here, it's the states are leaves here. Okay, I'm going to show you all this. Okay, so this is very, very important, and I hope everything is very clear. Okay, next is our query. Find all cities of United States. Okay, so find all cities of United States. That's our query. So we can use by descendant function to find all cities of United States. So we do say select, again it's one list, so we're going to have empty columns, okay, and on rows from operation. Okay, so here descendants function, so that's function have three parameter: member, level, and descendant flags. Okay, so first is member. So we want to have all cities of United States. Geography, have a geography hierarchy, and country name, region country name, and let's select United States. So that's our member. Now we want to have a level, or you can have a distance, right? So for first example, first thing is form 1 is distance, right? So we'll say from country, state, and we want to display all after. So after, we'll just select all of those, and I'll give you example for those. Okay, so this after we have country, is the country, and comma, distance is 1, and after, so distance 1 means states, and after means all cities. Okay, so it should display all cities. See all cities, these are all cities of United States: Chicago, Carol Stream, Columbus, etc. Okay, so that should be good. That's after. Now if we say if we put self should show us all the show us all the states, right? All states: Alabama, Alaska, Arizona, all states. If you see all states, okay, so that's good. After we also before, so before states in, so before states is a country, but it cannot go beyond the country because that is our point where we start, right? So it should be countries, and countries have only one, United States. Now self and after, what it should show: self and after. Self is states, after is cities. So self and after should say states and cities. You see Alabama, which is state; Birmingham, which is city; Alaska is state; Anchorage is a city; Arizona, all city and states. Okay, I see Plano. Plano should be Texas. Fort Worth. These are all okay. These are Texas. That's a Texas. Texas, Arlington, Austin, Backcliff, Baytown, Vermont, Carrollton, Cedar Park, etc. So this is the states and cities, right? States and cities. Self and before will be states and countries, right? Self and before will be states and countries. Self is states and countries, so it should show United States and all the states. Okay. Okay. Leaves, in this case states. This is not the, this is, we start with country and our leave is states because this is the distance. If you say 2, this will be city, so leaves should be states. So all the states, see, Alabama, Alaska, California, all states. If we say 2 left distance from country, distance 2, and then leaves, then it's a cities. That's a cities. Okay, so you guys are very clear, right? Right. Okay, so we covered the condition 1 or form 1. Form 2, find states and cities of United States, and this is actually we are using the form 2. So find states and cities of United States. So actually I should keep that form, this one, like our structure save somewhere, so I don't have to type every time. Okay, I'll keep a copy. Rows from operations. Okay, I'm going to keep this copy. Okay, now we don't have to type every time. Okay, so find all states and cities of United States. So we want to use the descendants. Okay, so this is our form 2. Form 2, and previous one was form 1. Okay, so form 2, one of your descendants, states and cities. So we're going to have states. Geography. Okay, so our first parameter is United States, and form to have a level instead of distance, so that is our level. Okay, state province name. Next, if you want to display city and states and cities and current state, what is the flag you should use? State you want to display self, right? Self. And after. Good. Okay, self and after. This is state, this is city. Okay, so it's good. Now all other flag will work exactly same. These flags will work exactly same, but I will try again. This is only difference is instead of distance it is now level. There is only difference here. Okay, but so self is states. This should show us states. That's right, Alabama, Alaska, these are states. After is cities. After is cities. That's right, Birmingham, Anchorage, Chandler. So these are all cities, and make sure there is no other things. These are all cities. Port Washington. Okay, so that's the after. Before would be state. Before state, country. How many country? Only one country, and that should give us a United States. Okay, self and after, we show that one. We already showed in the first. Self and before, this will be state and countries. Okay, state and countries. So you should see United States and all the states. Okay, cell before and after is a country, states and cities, right? Okay, cool. Leaves is again states. It's exactly same, distance and level are exactly same. Okay, only instead of distance it's a level now. Now that's our form 2. Now form 3 and form 4 exactly same as this is exactly same as form 1, except this is based on set. Okay, set. So instead of find all cities of United States, I added and Canada. So you can have two countries, United States and Canada. Okay, so let's do this. This is form 2. I'm going to copy exactly from form 1 query and create a new query, paste it. I'll change it to form 3 and all cities of United States and Canada, right? So what you need to do, this is not leaves actually, cities. So we say 1 and after. That's our, that should be, sorry, after, there should be all cities of United States. Okay, so that's good. Now if we need to add Canada, we're just using the Okay, and copy and paste and change this to Canada. Set ends. That's it. So now it should be all states, all cities of Canada and United States. F5. Now you say, okay, it looks same, but if you go bottom of the list, you see Toronto, Montreal, Ottawa. These are all Canadian city. Vancouver. Okay. So it's going to use this exactly same all other flags. Okay. Now if you say, it will be exactly like instead of United States, now it is just two countries. Actually, let's try one before. Let's try one before, and it should show two countries, United States and Canada. F5. It shows United States and Canada, right? So this is form 2. Now form 4 is exactly same as form 2. Only thing is that instead of one country, it is two countries. Okay. Control C, copy. Okay. New query. Paste. And this is our form 4. And cities of United States and Canada. Okay. For states and cities, we use this flag, self and after. F5. This should give us states and cities of United States. Now we need to add Canada. So instead of one member, we're going to make a set. Copy, paste, just make a set, comma. Now this one, we need to change this, change the country name to Canada. Okay, that should be done. F5. Now we see state, city, state, city, state, city, state, city, city, city. If you go to the bottom of the list, you'll see Montreal, Quebec, Ottawa, Toronto, Ontario. So we have states and cities. I definitely know this is a state, Quebec. Montreal is a city. Okay. Other one I'm not sure. I'm not sure other state name. Okay. So British Columbia. This is okay. This is state. Sorry. This is state, I believe. And Calgary is a city. Okay. So that's our descendant function. So our next function is add calculated member. Okay. So and query is find all calculated measures. We open a new query. Select our operation cube. Okay. So we have now our form. Okay. So you got this. find all calculated measures. So columns, we are finding one list, so columns is empty. So measures dot members, this will give us a name of all measures, right? This give us a name of list of all measures. And if we do, but it doesn't include calculated measures. What are calculated measures here? These are calculated members. Okay, so, and if you look at this, you'll not see those listed here. Okay, for example, sales gross margin, you'll not see sales gross margin here. Okay, so what you can do is add calculated members, or you can just this will display, this will list all measures including calculated measures. So for example, sales gross margin, that's a calculated measures. Okay, so if we do except or minus is a set, so total measures with the calculated measures, and now minus measures, so this should give all calculated measures, right? So inventory, you'll see inventory on hand quantity average, that's one, all list of the calculated measures, right? Okay, next query. So here is like measure members doesn't include calculated members, add calculated members, add the calculated members. Similarly, strip calculated members, remove the calculated members from a set. Okay, very easy. Now for strip calculated members, say for a given set, say we have this set. Okay, new query, say we have this set. So sales amount, sales quantity, we know these are non-calculated measures, and this is a calculated measure. So within this set, say strip the calculated measures, so it should display only these two. Okay, so we have our format standard skeleton, so put it here, and okay, okay, so that's our, let's make us a little bit, okay, so those are three, right? Good. So if I use a strip calculated measure, calculated members from this set, this should remove the sales gross margin, which is a calculated measure. So a strip calculated members. There's a function, there's the end of the function, but this should be set. So set end of the set, right? This should display me two members, this and this, right? What I did, calculate that. Okay, I have another extra e. Okay, good, perfect. Next is, so do you have anything here? Okay, this is one of the points. It is not necessary that all calculated members have to be measures. There can be members which is dimension. So we're going to show it later. So it's not necessary that we have to have all calculated members are measures. You can have in dimension too. Okay. So this is measure group measures. Okay. One thing I also want to say is there is two terms. It's very important you understand that two term, measure and measure groups. Okay. Measure and measure groups. These are different. You can have one or more measures in a measure group. Okay. So for example, if we in our cube you have a measure, these are measure groups. Sales is a measure groups. Sales amount is a measure. Sales amount, discount quantity, return amount, these are measures, and this is the measure group. So okay, so it says display all measures of measure group sales, correct? So the query is this. Let's copy. No, it's easy. I don't have to type every time. Okay. So we want to show the all measures from the measure group, right? So measure group name is sales, and we can use the function measure group measures, okay, for sales. That will display all the measures for the measure group sales. That means these are the value will be displayed. Okay, cool. So that's our measure group measures. What is next? Next is filter. Should be very easy. Okay, let me see. Okay, filter. So display sales quantity for product categories. Only show those product categories have at least 5 million sales quantity. Okay. So that's cotton. Let's paste here the query display sales quantity for product categories. Okay, we're going to do that. That's a step number 1. Okay, then we're going to do step number 2. Only show those product categories have at least 5 million sales quantity. Good. So let's copy and paste here. Okay, display sales quantity for product categories. Okay, that also very easy. We do sales quantity for product categories. Okay, sales quantity for product categories. Now we want to show those product category which have more than 5 million sales quantity. So first say 5 million. Which are the more than 5 million? This is 1.3 million. This is 3 million. This is 10 million. So computers should be there. Computers should be there. Then what else? What is this? Yes, this is cameras and camcorders. Cameras and camcorders. What else? Cell phone is 13 million. Cell phones. Okay. What else? This is 1.5 million. This 6 million. Games and toys. Games and toys. Right? And home appliances. This is also 10 million. So home appliances. That's a lot. Home appliances. Okay. So we want to do filter. Right? So we want to do filter. That's a filter function. And we got this. Filter in what is the condition? Sales quantity is more than 5 million. Right? More than 5 million. That's our condition. How many zeros? 6 zeros. 1, 2, 3, 4, 5, 6. Okay. So, and we should display whatever. Okay. So according to us, we should display computers, cameras, cell phones, games and toys, home appliances. Cool. Say we want to display something more than 7 million, then you should be displaying. Then it should be displaying computers. Right? If it is more than 7 million, computers. What else? Cell phones. Okay. Cell phones. What else? Home appliances. Okay. So that should be 7 million. So if I do 7 million, it should be F5 computer, cell phone, home appliances. Good. Okay, so filter. So this is a simple expression for filter. Measures sales quantity more than 5 million. You can have complex filter like and, or, etc. So for example, we have this one. Okay, so we have this one more than 7 million. So say we want to have a condition that it's more than 7 million but less than, it should be less than 12 million. So it should display this one and this one, computers and home appliances. So you can have say and, okay, so less than 12 million, say, okay, 12 million. So it should display computers, sorry, computers and home appliances. F5. Cool. So that's a little bit complex. You can have as many complex you want. Our next topic is all members. All members have two different types. One is hierarchy all members and another is level all members. Okay, so you're talking about all members. Okay, so find all members. Okay, let's make a new query. Select our cube. So find all members for hierarchy product of dimension product. So dimension product, so all members. Let's copy our structure. Okay, cool. So you can select, what do you mean by all members? All members means, let's see, okay, so all member display all, this is hierarchy, okay. So this is a all members for the hierarchy, and all members mean display all levels of the hierarchy. That means product category level, product subcategory level, product level, and also a level named all for all products. Okay, now here I show the sales amount. So the product all shows the sales amount, and all other audio is a category, right? Audio is a category. This is subcategory. This is product. Sorry, this is a product name. So this again, this result is a part of the result, but not the all result. So my caps lock is on. Okay, all members, and let's display the sales amount so that we can see the different values. Okay, F5. So here, as I said, this is all level, this is the all products. Audio is a category, this is subcategory, MP4, MP3, then this is the product. Okay, and if you see, you'll see there is a lot of okay, desktop, notebooks, that must be category computer. Okay, home theater system, computer, see, computer, then this laptop and all other stuff. So they have all product, all members means display all levels of the hierarchy. Product category, product subcategory, product, also display the all levels. Okay, so all members have two different form. One is for the hierarchy and one is for the level. Okay, so Find all members of the level product category name for dimension product. Okay, this is very important. You need to know the concept very well. So that's our query is find all members for level product category name for the dimension product. So level, for level, this one of hierarchy, basically to say of hierarchy product. Okay, so let's copy our and we're going to drag the sales amount. We're going to drag the sales amount. Okay, so that looks good, and we want to show the product, all levels of the product category name level. So that's level, this is the level, and I want to do it all members. Okay, now once we have this, what is this all level means? Display all product categories. That's right. Okay, note there is no all level. Okay, so not every level have a all level. These are user defined hierarchy levels. So this doesn't have the all level. Okay, so whereas, let's see, the last query shows this one. This is the hierarchy. The hierarchy have a all level, but not the level itself. Okay, the level itself doesn't have a all level. So for example, here product, that's all level here, but there is no all level here. There is no all level here. Okay, so F5, you'll see no all level, right? So that's the two form of all levels, all members for hierarchy and level. So our next function is, okay, we're going to use to set set A and set B for union, intersection, and union, intersect, and accept, and cross join. So okay, these two sets are very straightforward, very simple. So okay, so our query is top 10 cities have most sales in 2007. Okay, so let's copy our skeleton MDX. Most sales means sales amount. Okay, most sales doesn't mean how many item you sold. I'm assuming it's sales amount. So sales amount, and we're going to top cities. Cities geography. Geography is here. and city name. Okay, so this is like a sales amount for all cities for 2007. Okay, so that's a where clause, where condition, and then date. Here fiscal and calendar is same, so year is it 2007? 2007. Okay, so all city sales amount for 2007. F5 just to see everything is good. Okay, this is good. Lot of empty, but that's okay, looks good. Now we want to display the top 10. So what do you do? Top 10 means top count. Top count. Good. Top count. And how many top? 10. Top count. Sort by sales amount and complete this parenthesis. F5 should show me only 10 cities. Okay, top 10 cities. So that's my set A, and so set B is same thing, top 10 cities for 2008. Simple. So basically we just want to change the condition is like this, same thing, change it to 2008 5. So that's a, actually we can copy and paste another query. Okay, so this is for 2008. Top is basing, and this is 2007, and who's the top? North Hartford. So North Hartford 2007 and basing in 2008. This again, this is a fictitious data in a context database. Okay, so that's 2. So next is our, so find cities in top 10 cities. Find cities in have most sales in 2007 or 2008. So it says that basically find all cities. Find all cities in top 10 for 2007 or 2008. So basically you say include both. If it is either 2007 top 10 cities, find all cities in top 10 cities in set of top 10 cities have most sales in 2007 or 2008. Okay, so what are you going to do? we need our basic okay. We want a set of, so first of all we're going to show the sales amount. Sales amount, so this is good. Okay, and then in the rows we want to show union of two sets. Union of two sets, or we can create a named set. So with set, say top 10 cities for 2007 or 2008. Okay, as now this, so we can say here it's a set, right? It's a set of, okay, so top count, okay, top count, and I'm just trying to get one top count. Basically I'm going to want this one. Okay, so we don't need to, okay, so okay, so now this is the top 10. This is okay, so this is good. This is for all years, top count. So if we display, this will be defining, showing us, say here, display all of them, right? It is not the 2007 or 2008, it is for all years ever. Okay, because we don't have any condition. Now if you say to make it 2000, to make it 2007, how we can make it? So this is the city name, and here instead of only sales amount, we can say sales amount. We can define a tuple. This is nothing but a tuple for the on the sales amount. We can always define a tuple here and say this is 2007. Okay, now this is not right, but what I can do is this part, okay, this part I can make here as a not 2008 but 2007. Okay, so this gives a sales amount for 2007 and find the top count for the city. It's very important, very important. You'll find you need to have this concept clear. And F5, so this will give us a 2007. Now 2007, remember 2007 North Hartford was the top, right? This is 2008, I know, Beijing. This is North Hartford, right? Good. So if you want to show the 2008 and 2007, so just copy and paste here, and union. This one and this one, comma, and this one, 8. Okay. I want to tell you one thing before that. Okay, let's talk about the existing one. So this is we have for 2007. Now I believe you notice one thing. So North Hartford is sales amount is this one, this number, and if you look at here 2007, North Hartford sales sum is 418, whatever these numbers, which doesn't match with this one. Why? The reason is this top 10 cities, this is the top 10 cities. What is the result of this set? City name, right? And here is a sales amount without any condition. This is city name, sales amount. So this is showing sales amount for complete database. If you need to do other filtering, you can do filtering here, where condition and everything. Okay, so just to, I believe we should know that this amount is not exactly this amount from 2007. Okay, now we want to show cities union, either. Okay, so that's our union. This is for 2008 top 10 cities, this is for 2007 top 10 cities, right? And we are doing union. Okay, and select, perfect, F5. So that's our. Now we can say here, this is nothing to do with the, this returns no yearly data, it returns name of the cities. You have to be very careful here. This returns name of the cities. How it get name? It get name for top count 10 for the year 2007. That's right. But this is nothing to do with the year. This gives name of the cities. Okay, sales amount. Now if you want to see those all cities, you want to see the sales amount for 2008, you can always make a condition 2008. That should show you sales for 2008. You can change it to 2007 if you want to see, and you can see 2007. So our next query, so we did the set A, set B, union, intersect. Also very simple, and we're not going to spend a lot of time because it says okay. say and instead of union we want to do intersect. Okay, so we want to find out, this query is find cities in top 10 cities of most sales in 2007 as well as 2008. Name of the cities which made both the list, top 10 2007 as well as top 10 2008. Okay, so that's intersect, and we want to show 2007 values. F5. Okay, this is, we change the name here, we change the set name here. Okay, F5, that should give. So these, how many cities? 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. So 7 out of like 7 cities made both the list. Okay, our next query, okay, find cities in top 10 cities most sales but in 2007 but not in 2008. Okay, so that's one. I have 2007, it is in 2007 but not in 2008. So what do? You do accept, right? 7 minus 8. Okay, so we're going to okay, so that's the 3 cities which made in 2007 but never made in top 10 list of 2008. Okay, so that's our okay, this is I believe a part 2. We complete part 2, so we complete this part, we completed this part, and we are starting the most crucial one. I know this chapter is, this session is huge, really huge. You guys can take a break. It's already 2 hours, or you can pause your video and come back, and we'll start, because we need really concentration for the next next part. So we are starting again after a break. So next query is, next function we are going to talk about is cross join. Unlike SQL Server, cross join is used more frequently in MDX, and this is our first query. New query, and so find sales amount for each product category for each year. One thing I want to tell here is, what is cross join? Cross join is the Cartesian product of 2 sets. So either you can use the keyword cross join, or you can do alternate syntax like star. So okay, two sets. This cross join is between two sets. I mean two, or you can have multiple, and then between two sets, and then so this is a product category name. This is one set, and all fiscal years. This is another set. Okay. So our query. Let's copy our skeleton, and so sales amount for each product category. Say let's do the first part. Sales amount for each product category. Okay, and this is will be our second part, and we'll do the first part here. Okay. So select our cube, find the sales amount, okay, and the product category, product category, F5. So that's our product category. Now you want to do for each year, so you can do cross join, and then the year. So here we go date and fiscal. As I say, fiscal and calendar is not difference here. So now you can see the category for product category, sales amount for product category for each year. F5. So product category, year, the values. Product category, year, the values. Product category, year, the values. Okay, sales amounts. Good. Now, for example, product category, years, and you want to do by country, for example. Okay. So by country, you can. So I'm sorry. So the alternate syntax for this is like you can either use the keyword cross join, or you can do like this. You can just use a star. This will give you the same result. And now, for example, you want to see product category fiscal year for each country. Okay, so that means you want to have another cross join which is for the country. Okay, so geography, country name, and if you cross here, then you'll see by the country. Cross F5. Now you will see product category for the year, country. I will have to find out which have value or not. So use list. Okay, good. So let's go back to our original query. So product category for the fiscal year. Good. Our next function is extract. So extract is a so from the cross join, if you want to like say for example we have this cross join, there's a year and the category. Extract function extracts any of the hierarchy, either the product or the fiscal YQM. Okay, so for example, from the last cross join, list all distinct years. Okay, so that is our goal. Our goal is to, from this cross join, extract distinct years. Okay, so our cross join is here. So you can write a extra function extract. Okay. Now one thing is, the second parameter of extract is the hierarchy. Okay, it's not the fiscal year, it's not the level, it's a hierarchy. From this hierarchy, whatever the current value is. Okay, so two parameters, one is the cross join, second is what hierarchy. You can do either this or this. Okay, so F5, so you got it right. The extract function, this is the cross join, and what we're going to find out, what we're going to extract. This should be a hierarchy, right? F5, that's give you all fiscal years. Good, very simple. And again, my idea for this course and MDX is to explain you all this function, all these things in simplest form. We can go as complex as we want, but the goal for this course is to understand all the function, understand conceptually is clear, then you go and explore more. Lot of cases those functions are not very clear in the online books or any other books, and I believe my intention to make it simple, not complex. I mean, I can go as complex as you want, but I want to do a simplest form so that you can understand clear and you can understand easily. Okay, so our next function is non-empty cross join. Okay, so non-empty cross join. Let's copy and open a query. Okay, let's do our normal cross join. Okay, and you must saw there's a lots of empty values. Okay, so what you can do is to show only non-empty values. What you can do is Okay, first let me make a copy, then I'll make a change, because we can have two form of non-empty. One is by using the non-empty cross join, and without one other is not using. Okay, so non-empty okay cross join, and we want to show non-empty for okay, so this will show all the non-empty values, right? F5, it will show you all non-empty values. But so in but we can use by other function also non-empty cross join, and this shows only non-empty values and only associated values which have a associated with the values. All calculated members are excluded for this non-empty cross join. So instead of cross join, we can have a non-empty cross join. So for example, okay. So we copied here. Oh, okay. So that's our query look like. Only show non-empty values. So what you can do, it's very exactly same actually. Non-empty cross join, and this is comma. Okay, F5. So this will show you all non-empty values. Good. And one condition, it doesn't show the calculated members. Good. Our next function is range. Okay. Okay, I have two forms of range. Then we have exist. Range. Okay. Let's copy the string, minimize this, open new query, and that's our query. Show sales amount for each month from February 2008 to November 2008 for state of Texas. Okay, so that's our goal. Okay, so what is different part? Let's copy our skeleton MDX. Our skeleton MDX. Okay, so this is good. Sales amount, we want to, so basically we want to have sales amount. This is show sales amount. This means this is columns, right? For each month means this is rows. Okay, each month means every month, right? So for state of Texas, this means this is condition. Good. Or condition or a where clause. Okay, so sales amount, that is in our columns. For each month of February, from February, that will be using the range function, range operator. Okay, and condition is Texas. So let's select our cube, sales amount. We're going to do the sales amount. So that's our columns. Looks good. Month February 2008, and it is very simple. Actually, the range is very simple. So fiscal month February 2008, doesn't matter. Okay, and the range operator is colon from February 2008 to November 2008. That's November 2008, and our condition is Texas, state of Texas. So that is in geography, state of Texas, state. So our where condition, and I'll just I'll retype this. Lot of states, so I just grab one and change it to Texas. So this should give me all the months, sales amount for all the months for state of Texas. Good. F5. Yes. So this is sales of Texas, February 2008 to November 2008. That's our range operator. Very simple, right? Okay. Next. So that's a cousin function. This is practice, I said. Colon between two values defines the range. Okay. Show the sales amount for each month of February to cousin for. Okay. What is cousin for? Okay. Show sales amount for, so we know already this is the column, this is the row, and this is the Texas. Okay, now what is cousin for year 2008? February is, so February is here, new page. Okay, so we have this is the like a root. Say we have, this is 2008, right? 2009, and then we have Q1, Q2, Q3, Q3, Q4, just Q4, then Q1, Q2, Q3, Q4. Okay, then we have month, right? 1, 2, 3. 4 5 6, like that, right? Dot dot dot. Q1 also have 1 2 3 and etc., right? So now if we said February 2008 cousin, so cousin would be, what is the question? For each month from February 2008 to cousin for 2009, what is the cousin for 2009 for February? Cousin of February 2008 for 2009. So basically it's saying these are the two pairs, right? And cousin is here. This is the cousin. So saying that February 2008 to February 2009. Good? Okay. So actually we can just copy the last one. It's exactly same thing, only we're going to just replace the next one here with the cousin value. Okay, so cousin of February 2008. What is the reference? Is 2009, right? February 2008 to cousin for year 2009. Okay, so date, fiscal year 2009. And so now it should be showing us all the months value from February 2008 to February 2009. Okay, F5. So February 2008 to February 2009. Good. Okay, next query. Okay, so it have another one. So we did this good for year 2009. If we do, it's not only one way, we can do cousin for 2007. So it will go keep from 2007 February to 2008 February, F5. So 2007 February to 2008 February. It's not only one direction, it's bi-directional. It doesn't have a direction actually. So okay, so that's our cousin exist. Okay, so our next function is exist, and let's create a new query. Select our cube and So limit the product categories for the following subcategories. Okay, so okay, so let's copy our skeleton MDX, and this query basically you inspect that, observe that, and so we want to display all the categories which have these subcategories. Okay, good. So exist function limits the categories, not displaying all product categories. So say for example we have what do you call measures, sales amount, okay, and we have all product categories. We have all product. So if this is the case, I mean, we can use either these or we can use these also from the hierarchy. Okay, so this is the, now I want to limit for this product subcategories. Okay, so if you want to do that, so first want to create a set, and set would be for this, and subcategory, so just okay, subcategory name I'm going to do laptops, not a key value, it's a, okay, one two three, okay, radio, headphones, radio, headphones, okay, okay, so this is our subset, and we want to limit our product categories. So this shows all product categories. So exist will limit our, so that's the limit set, okay, and that's the end of the function. So now laptops is computer, radio is audio I believe, TV and video, headphones I believe audio, so it should be audio, TV and video, and computers, right? Audio, TV and video, and computers. F5. Okay, so laptop is computers, radio is audio, headphones is audio I believe, television is TV and video. So we limit the product category set. Okay, our next function is most important. We talked about one descendants, and this is another one. So generate is very important, very important. So what is generate function does? It have two form definitely, but let me explain what it does. It loops through a set and apply the other set. So say form A, form 1. So form 1 has a generate function set A and set B in all. Okay, set B applies to each member of set A. Set A is a base set. Set B is applied. So if set B, now if this like if set B is depend on set A, union them all. Right? And third member so I'm saying this set B applies to each member of set A if set B is depend on set A. So this condition of application, okay, we said applies. This applies is totally valid if this statement is right. If this statement is not right, then it's only set B. I'm going to give you a whole example. I mean, I'm just trying to give you a concept, and then we're going to give all example one by one so that everything is very clear. Okay, I know it may be a little bit confused. Then union them all. If third parameters all is passed, duplicate values are displayed. If not, there will be no duplicate. Okay, so this is for the set. The set B is this is set B. Okay, form 2 is very similar to form 1, but set A and string B and delimiter C, so created by string B, applies to each member of set A if string B is depend on set A. This applies to this if it is depend, and then it creates a string. The string will be concatenate with delimiter. If there is no third delimiter, there will be no delimiter, but ultimately there will be string. So I know I confuse you enough, but we'll give one example at a time. Okay, we'll be going through each example one by one, and I'll give you very simple and concept. I know a lot of places generate function really confused, but I guarantee you will be totally clear. There's two form. One is for the set form 1, second form is for the string. Okay, for this time remember these two things only. Form 1 is for set, form 2 for the string. Okay, cool. Okay, so this is the form 1. Let me see what we have. I'm just looking, so give me 1 minute. I'm just looking what I have. Okay. Okay, sorry. Okay, so basically inspect the query. I need total of your concentration. This is very, very important. We create a new query, and I'm going to create two name set. So this is just a inspect the query. So with set set p as, before that I'll create a member member product. Okay, as p1. We just assume this sets a member so that it's easy to understand. So I create three members for the product: p1, p2, and p3. Okay. Okay. And I'll create a set which is called set p. Good. And that should be very, very simple. Okay. Same thing, we're going to create some other member okay, and this time we're going to create for channel C1 is C1. We're going to create three more, or two more. 2, 3. So see, I'm just creating P1, P2, P3, C1, C2, C3, so that you can understand easily. And I'm going to create another set also. Set C as okay. C2. Okay. So we created three members, P1, P2, P3. We create a set P which consists of three members, P1, P2, P3, and okay, and we create a channel three members, C1, C2, C3, and set C. Okay. Now we're going to use the generate function. Okay, so to make it simplicity, we use our skeleton Okay, so this is good. Now we are going to do generate. Our base is set p, comma, say we have set c, so generate set p and set c, and that's it. What will be the result for this? We generate set p comma set c. So let's look at our definition. Okay, set b, set c, all, forget about all, because we can actually add all, so that we see all. We want to see the duplicate also, and later on we will change. So this is the form 1. Okay, so we have a set A, which is our set P. Actually, why not just change it to, okay, that's fine. So set A, set B. If set B applies to each member of set A, if set B is depend on set A, so our case set C is not depends on set P. It's not depends on set P, but is going to apply each of the things. So for example, here is going to apply set C, C1. So for here it will say C1, C2, C3. For this it will say C1, C2, C3. For this it will say C1, C2, C3. So we have 3 times you'll see C1, C2, C3, because this is not depend on this, right? So this result, what I'm trying to say is, so you have P1, P2, P3, but that's right, but for this case there is nothing connected to P1 to this value. This expression doesn't have P1, so we have C1, C2, C3 for this P1, for the first P1, this value. Okay, next time again it will be repeated 3 times, but we will not see any of the P1 trace of P1, only you'll see C1. So you say C1, C2, C3, C1, C2, C3, C1, C2, C3. Okay, let's see another comparison. Let's see. So this is the condition, I believe. Not this is the condition I was talking about. Okay, so in this example, second set of generate function is not depend on the first set, and the result is the second set. Why second set? Generate means set C applied to set P means 3 times. C1, C2, C3, one of each for each item of set P. Okay, let's see this one. I was discussing this one because I believe this is easier to understand, and then I'm going to go for a little bit complex. That's this one. Okay, So say we do so what does this means? For P1 there will be cross of P1, P2, P3. P1 okay, I'm sorry. Okay. Now this set is depend on set P. Okay? But as we used all, every cross product is a 9 element, 9 objects. P1 have 3, C1 have a 3, so 9. 3 times 9, so it'll be 27, right? Each cross join is 9 items. P have a 3 items, so totally 27, right? F5. So you have a lot of, because for each P1 it is showing the cross product, which is equal to 9. But if you say, okay, don't show me duplicate, remove the all, now you will see only 9. P1, C1, C2, right? What is this P1 is coming from? This P1 is coming from this cross join of this and this. This P represent P1 represent this one, right? So as the cross product is 9 items, P have a 3 items, total is 27. When it's a duplicate allowed, it shows 27, right? Good. Now okay, so that is good. What is our next query? Okay, that shows the difference, all and without all. So if it is depend on this, what I was trying to say is, okay, now if I remove the cross, and now C is not depend on P, second set is not dependent, so 3 times when you allowed all, see, for P1 it will display 3, C1, C2, C3. For P2 it will say display C1, C2, C3. For P3 it will display C1, C2, C3. So this is the condition, C1, C2, C3, C1, C2, C3. This is for P1, this is for P2, this is for P3. Now if you remove all, it's not going to show all 9, it will just going to show 3 of them. Good. So that is, I believe, my this one. In this example, second set of generate function is not dependent on the first set. Generate means set C applied to set P. No repetition result as we remove the third parameter all. Okay. So I believe this is set is okay. My next query, for each year So let's open the SQL Server Management Studio. So for each year, find the product categories which have sales amount more than 800 million. Right? Okay. So for each year, find the product categories find the product categories which have sales amount. So we want a sales amount. So first is, let's copy our skeleton MDX. Let's copy our skeleton MDX. So this is good. First thing we need to display the sales amount, right? Sounds like it. Okay, we did sales amount. Now find product categories which have sales amount. We want to do a product categories. First is, so display first product categories. Okay, so display first all product categories. I'm okay with that. So display first all product categories. Now this is good. Now show me only those product categories which have sales amount some value, right? So what is the condition? So condition is filter, right? Show me only those product categories which have some value. So only those which have sales amount greater than 800 million. Okay, 806. 1 2 3 1 2 3. That should be filter. Okay, good. So now it's going to show the product category which have sales amount more than $800 million. Okay, these are the which have more than $800 million, right? Okay, so now question is, we want to do it for each year. So we want to do by each year. So basically we need to loop through the year, right? Loop through the year and then find if the sales amount is right, sales amount is more than 800 million. So loop through the year, okay, for each year set. So that will be your generate function. Good. So I'll generate. Okay, so our generate function what is that? First thing we want to do by loop through the year, right? So our base looping through which, that's a year. Okay, so that's the year, looping through the year. Now filter. Once you loop through the year, you get the current member. Right? So current member, that makes it current member, and cross join with the product category name. So this depends on these values, right? And the condition is more than 800 million. I don't know if I give the right number or not, but okay, F5. Okay, so that's right, that's totally right. So it's going to looping through these things and saying that which okay, which have more than 800 million. But one thing is, this amount is not for the year. This amount, what it shows, is total sales. Okay, good. Let's see what I have. So generate is like looping a set. Generate is like looping a set. Question is, when do we need to use generate function in the query? So sales amount greater than 800 million is not depend on particular year, but it is a variable year. So we need to loop through the set of years and evaluate sales amount for each year. Okay, so that's the point when you need, excuse me, generate function. Okay, so we have, so this function, this form, the second form of generate function is a string, and last form was for the set, and this is for the string. And if I go to, so display all the product categories in a string separated by dash. That's our goal. So let's copy it and go to new query, select our cube, and okay, so let's copy our skeleton MDX. We just want to display one string. So one string, we don't need the rows, we need only columns. So, and we're going to create a member. So with member, measures. So we have we name it, say, product categories string. Okay, as, so we're going to write a program to make a string, and we're going to display this value here. So if this, say, test string is going to display test. So if you remember our string form, I'm trying to go back to the string form. This string form, set A, so that will be our, set A would be our product categories, all the product category name, and string B will be dependent member, whatever this function expression is. For our case it will be a current member, okay, and delimited by dash. Okay, good. So here we want to generate and the product category name. So from the product we want to select the product category name. Okay, our set B is the current member from the hierarchy product. So current member and delimited by dash. Okay, so now a string will be created with each product category and delimited by dash. F5. Okay, we got an error. Okay, so we did what I did is a current member, and we want to do the name of the current member. Sorry. Now F5. If you selected here, what is a loop dependencies? Okay, F5. So that's will give us a, because we didn't tell what to get. So now it's all product categories. Okay, let me see. Okay, so that's all product categories delimited by the dash. Good. So that's our second form of the generate function. So that's end of our session. Not say, I mean, we have exercises. So that's the last topic. Exercises. So as I told earlier, okay, we have eight exercises. And I want you to pause the video and using your booklet do the all exercise yourself, and then try to match your answer with my answers. Sorry. Okay, so now once you tried exercises, let me give you a solution. So So first one, so our query is find sales quantity for each year. Also create a year header which have for in front of each year, like for 2007, for 2008, etc. Okay, for actually for year 2008, for year 2009. Okay, so let's copy our skeleton MDX. We want to display sales quantity, so definitely we're going to grab the sales quantity from the measure, and that's a sales quantity. Okay, for each year. Okay, so I'll go to the date function, and we can do calendar year, fiscal year, both are same. So let's do here calendar year. Actually I was grabbing from here. It doesn't matter. So that gives us for each year the sales quantity. Now we want to have another, create a year header, so that is nothing but another member. So with member measures dot year header as, so we want to have the current member for the year, current member dot name. So this is the year header. So we can display our sales quantity and year header just to display the year. So you are good. This. So we don't want to show the null values, for example. So what do you do? Non-empty. Okay. Sales amount. Sorry, sales quantity. So this will give us a non-empty values. Right? Okay, this is good. Now it says for the query says you need to add for, right? So what you can do is very simple. We just add a string called for, and that's it. It will show us a for year 2007, 2008, 2009. Good. Okay. So next query. Okay. Find last 5 products from the list of the products using the function tail. That should be very simple. So let's copy our skeleton MDX. First column is empty because we just want to list one. So from all products, sure, all products, not the product category. So all products. So this is the all products is going to display. Okay, and we're going to display tail, and we want to display how many? 5, right? 5. So it's going to show the tail 5 because this is the last member. So good. Next query, bottom 5 product based on sales quantity using the bottom count. These should be very easy. This, so we're going to modify this current one. So find bottom 5 product. Okay, so we'll be using sales quantity, so we'll display the sales quantity. Sales quantity, and instead of top count we'll use the bottom count, right? Bottom count, that's right, 5, and then based on sorting by sales quantity, right? 5, so that will give us a bottom count. Okay, easy. Next, bottom 5%, very similar to that. I'm going to use so bottom percent F5, it's a lot of bottoms. If you're coming from the bottom, you need a lot of products to cover up to 5% of the sales quantity. So that's our 4. Number 5. Number 5 is, I'm going to use same. Show only those product categories which have at least sales quantity 10 million cumulatively, starting from the lowest this is, I did a misspell, this is the sales quantity, and growing towards the higher amount, right? So what function we're going to use? Bottom sum. Instead of percent, it's a sum, and we're going to use here 10 6 zeros. Okay, quantity, and that should show us the bottom sum. So that's our 10 million. It's a lot of Okay, these are easy. Next one, find number of states in Europe. Okay, that's interesting. Close everything and open a new query. Think about it, how can you find it, and then solution. Find number of states in Europe. What is Europe? Europe is continent, right? And Europe is continent, and we should use the descendant function, state level, continent to continent, country, state, right? Continent, country, state, and we use the self. So we want a descendant. I'm just thinking loudly. Descendants, and we need to have a continent here. So geography, continent, we want a continent name here. Okay, and we're going to use level. Next level is state. What is state? So, and okay, we want to use self. And then we're going to do a count. That's it, right? So this should be good. So you may think about, okay, this is the function this is the structure we are thinking about, and I'm just thinking as a SQL user how it could be look like. You may think, okay, this is very simple, count, right? So do a select, and we want to select only one. We don't need a rows here, and you may say, okay, that's fine, this is good here. Okay, right? Let's see first how the, so this is good, this is the default amount, and it's showing the all states. And you say count, so here the function expects a set expression argument, a string or numeric value is used. Okay, this function here needs a set expression. You're using a numeric value, so this is not right. What you can do, what you have to do is you create a member, calculator member, with member measures, say state count, Europe state count, yes, that's the value, and you display this value. Now this is a, okay, so good, F5, so that's give you 55. Good. Okay, next one, next one is here. Open a new query. So it's a find sales amount, sales quantity for Texas, these two, for Texas, Florida, and New York. Okay, for year 2008 2009. For the products, how do you sell cell phones? Okay, if you look at closely, let's copy our skeleton MDX. Okay, so sales amount, sales quantity is in the columns, we know for sure, right? This part is in the columns, right? We're good. So let's add the sales quantity and sales amount. So sales amount, we got it. Sales quantity. So this is good. The first line is good. Now, for Texas, Florida, New York, for year 2008 2009, for product, what do you feel? These three are cross join. Okay, it's a Cartesian product or cross join. So this is the first member. We have to do the cross join with this, with the year, this one. To make it simple, more clean, what I'm going to do, we're going to create three sets. One set is for this, one set is for this, and one set is for this. Okay, so with set, we're going to set the states as my states or the states. Okay, we're going to grab Texas, Florida, and New York. Okay, geography, state, Texas, Florida, New York. Okay, Florida and New York. New York. So if we do this, in the states, so it should show sales amount and sales quantity for these states, right? F5. So you got correct. We're saying Texas, Florida, and New York. Sales amount, sales quantity. We're good, right? Next set. We're going to create a set for the year. So set the years as okay, date, and we can use any of those, but let's say I'll use this one. We want 2008 and 2009. 2008 and 2009. See, years 2008, comma 2009. Okay, so we can do cross join on these two, and it should be simple. Star the years, F5. Now you see for Texas 2008 2009, for Florida 2008 2009, for New York 2008 2009. Next is we want to create a products, audio and cell phones. Okay, next is set the products as products. We want product categories, and we want audio. Okay. Oh, it's a set, and we can do all this audio. I'll just copy and set. Okay, I want to see what is that cell phones. You have to make sure that you spell correctly. Cell phones. Cell phones. Okay, then you do a Cartesian product for the products too. So now it will be for the year, for the state, for the year, for the product. F5. State, year 2008, audio, cell phones. State 2009, audio, cell phones. So it's all product. Good. Okay, so last one. I assume this is very close to this one. Okay, let's open a new query and see what it is. Find sales amount, sales quantity, that's same to the last one, for state years. For years actually, not state, I did a misspell. For products, okay, no, I'm sorry, I'm wrong. Actually for states, he's not mentioning the states yet. For years 2008 2009, for the products, audio in this thing. So this is we have up to this, right? Now show only states that contain the following cities. So we have to work with states. So we just copy our existing query and see what it look like. Okay, so we have this. So I'm thinking these ones sorry, this is my old. So states containing the cities, Dallas, Austin, Los Angeles. I'm thinking this one as a exist function. Okay, so let's create the city's name first. Okay, so we'll create instead of, we'll say cities, the cities. Okay, and geography, city name. I just grab a sample city. Okay, and delete everything here, and we have, these are the cities we have. how many cities? 1 2 3 4 5 6 7. Okay, 1 2 3 4 5 6 7. So Dallas is the first one. Dallas. Austin. So Dallas and Austin is it from Texas. Okay, so Dallas and Austin from the Texas. Then Los Angeles is California. So California. Chicago is Illinois. So that's Illinois. New York is New York. New York. Buffalo is New York. Again. Orlando is Florida. And Miami is also Florida, right? Just to make sure we got that. Okay. Okay. So that's the cities. So what we're going to do is we have city, we have years, we have products. So this is good. This is good. This is totally good. Years. So states. So we want to do only states which is from this. So that's there. So we're going to use exist function, right? We don't have state here. And beginning and end. And we're going to use the all states. So these will give us a all state, right? If we don't use exist, this will give us all state. Now we want to limit this all state by the cities. Good. Okay, now it should display only those states, only those states have these cities. Good. Have 5. Okay, let's see if California, Florida, Illinois, New York, and Texas. Totally good. Because 1 2 3, yeah, because we see if anything miss. Dallas, this is Texas, this is California, Chicago is Illinois, New York is New York, Buffalo is New York, Orlando is Florida, Miami is Florida. Okay, we have Florida. So that's good. That's the end of the. So you have 2 exercises I gave answer in the booklet, A and B, 2 pages. That's the end of this session. I know this session took a lot of time. It's a long day for me. And I try to accommodate everything and as a set function here, and I put a lot of effort to make this session, and lot of new like conceptually easier to understand examples, as well as as well as I try to write all the query from the beginning to end typing, not cut and paste somewhere. I know a lot of trainers do have an inbuilt code and just cut and paste and do. I know those are fast and show the result first. That is not, I believe more important is that you learn in detail what it is, how it is. My intention to make this MDX query, a lot of time I always told you guys that I open the Management Studio, cut and paste the query. Definitely I go through those query, I made those query, I know very well, but when I try to show you, I try to show from the beginning. I try to show you how a person can think about how to structure that query, how to not just a cut and paste whole code and say okay this is working. No, I mean we have to be like as a explain, as I'm explaining the MDX, I have to explain why I'm doing this part, why I'm not doing that part. Sometimes you may be a little bit surprised because yes, I looked at the query, I prepared the query, I know what it is, and but still I try to present you that that I don't know that part of the query. How can I think? Sometimes I show you how what kind of error you may face, and you know I believe like I hope you guys understand everything very well, and give me feedback on my I gave you the email address training@egurus.com, and you can send me question if you have a like any issues in this training booklet or video, or you have something you want to discuss, but I may not have enough time if it is a long discussion. If it is a quick discussion or a simple email, I can write a simple like MDX, you know. So you're welcome to send me emails, but one thing very sure, that you have to send me the product ID, your name, your information. Other than that I don't entertain. So you have to make sure that you have a password, not a product ID. The password should provide you a password to access this video, because these all videos are encrypted. You cannot run a normal video, so you have to refer that password so that I know which one you are, I mean your identity and everything. Okay, thank you very much. I hope you enjoyed it, and if some topics are not you know I didn't take enough time, so please you know rewind and listen a couple of times, try to understand what I'm trying to say, read the training booklet. That is, I put a lot of effort to do that. Again, I assume that if there's a small mistake or a small typo, you guys are smart enough to figure it out. So you know, I saw a couple of typo. I'm going to try to fix those in the training booklet, but most of the cases is good. You know. Okay. Thank you very much. I'll see you next session. Thank you.